This is section 3.2, logarithmic functions. So for a logarithmic function, it's going to look something like this. F of x is equal to, this is read log base a of x. X has to be greater than 0. A has to be greater than 0, and a is not allowed to equal 1. So as long as we have that, then what we have is the relationship here. Y equal to log base a of x is the same thing as x equal to a to the y power. So here we have a logarithmic form, here we have an exponential form, and we can convert back and forth. Now, being able to convert back and forth is a very important skill because it's going to enable us to solve equations in a later section. So logarithms and exponentials are inverses of each other, and the definition above allows us to convert back and forth. Okay, so for these first problems, we're given something in exponential form, and they want us to write it in logarithmic form. So let's just compare what we have here to what is right here. So 1024, that is my x value. 2 is a, and 10 is y. So if I want to convert this to logarithmic form, I have 10 is equal to log base a of 1024. They don't want us to do anything more than that, just to change it to logarithmic form. Now notice here, I know a lot of you do not use cursive anymore, but I've used a cursive L. And the reason for that is that it is very easy to mistake the L in front of a log as a 1, and it will mess everything up. What's more, in my math lab, the font they use, you cannot tell the difference between a capital letter I and a lowercase l. If you type in an uppercase I, it will count all of the problems wrong. So you want to be really careful about that. Okay, now let's go on here, and I want to convert 9 to the negative 1/2 is equal to 1/3. 9 is your a, negative 1/2 will be your y, and 1/3 is your x. So we have y equals, so negative 1/2 equals log base a, and a is 9, of x, which is 1/3. Okay, often you're going to see a fraction when you have it belonging to a logarithm. You're going to put it in fractions. This number here, whatever is right here and right here, that's called the argument of the logarithm. Okay, now let's do this with p is equal to a to the q power. Now, so a is a, q is y in our formula, and p is in the x position. So what we have here is, since it's y equals, so q equals log base a of x, which is p. So we've converted all of these from exponential into logarithmic forms. Now we want to go and do it the other way around. Now notice right here, because it's a little bit easier to see this as an animation going from logarithms to exponentials, and what's going on here is you can imagine this number swooping over to here and bumping that up. So the 2 pushes this up to be an exponent, and then it's equal to what you have right here. So if I want to convert these from logarithmic form into exponential form, we're going to do basically the same thing. This 2 swoops over to here, and it bumps that 6 up, and it becomes an exponent. So I end up with 64 is equal to 2 to the 6th power. And now we're going to do the same thing here. This bumps the w up, and you get u is equal to v raised to the w power. Okay, so now we're going to have a few problems where we are asked to evaluate a logarithm by converting it to exponential form. Okay, so I want to know the value of log base 3 of 9. So what I'm going to do is I'm just going to set this equal to a variable. I can do that. I want to know what it equals, so y is what it equals. Now let's switch it to exponential form. So this comes over to here. And we get 9 is equal to 3 to the y power. Now what you want to try to do is to rewrite them, each side, so that they have the same base. And I can rewrite 9 as 3 squared. And then from this, we know that these are 1 to 1. We learned this in the last section. So we can drop the base of 3, and y has to equal 2. So log base 3 of 9 is the same thing as 2. Now let's do the same thing here. Log base 9 of 1/3. I'm going to set this equal to y. And then we're going to move the 9 over to here. So we have 1/3 equal to 9 to the y power. Now I can write 1/3 as a power of 3. It is the same thing as 3 to the negative 1 power. And I can write 9 as 3 squared. So I have 3 squared raised to the y power. Now one of our exponent rules is that if you have a power raised to a power, you can multiply those together. So I have 3 to the negative 1 is equal to 3 to the 2y. And now, since I have the same base on each side, I have negative 1 is equal to 2y. Therefore, y is equal to negative 1/2. So log base 9 of 1/3 is the same thing as negative 1/2. All right, log base 1/2 of 32, set that equal to y. Now the 1/2 swoops over here, and you get 32 is equal to 1/2 to the y power. Both 32 and 1/2 are powers of 2. 32 is 2 to the 5th power, and 1/2 is 2 to the negative 1. So what I have here is 2 to the negative y. So that means 5 equal to negative y, and your y value is negative 5. So log base 1/2 of 32 is the same thing as negative 5.